Welcome friends. Today we'll see the interference in involute gears. Now first of all, if you see the pitch circle of the pinion and the pitch circle of the gear, they are always meeting at one point, that is called as a pitch point when the two gears are in meshing condition. Now here this O1, it is the center of the pinion, and O2, it is the center of the gears, and Mn, it is a common tangent to the base circle of the pinion and the gear. If you see the addendum circle of the pinion, it intersects at point L to common tangent Mn, and actual addendum circle of the gear, it intersect at point K. Now this K to L, this is called the length of path of contact, and out of that Kp, it is the length of path of approach, and Pl is the length of path of recess. So addition of these two gives you the length of path of contact. Right. Now we can increase this addendum circle. That means we can move this point L to N. If you see this diagram carefully, see the actual addendum circle, it is intersecting to Mn at point L. You can increase this radius of the addendum circle up to the N, which is shown by this dotted line, O1 N. Now if you go beyond that, then your contact point will move inside the base circle, right? So that means this O1N, this is the limiting addendum circle radius. So we can say the maximum addendum circle radius up to which we can increase the radius or the diameter of the addendum circle. If it goes beyond that, definitely it will go inside the base circle, and when it goes inside the base circle, due to that, so your contact point will go inside the base circle. That means it cuts the base of the wheel or the gear, and that phenomena, that is called the interference. That means phenomena when the tip of the tooth undercuts the root on its mating gear is known as the interference. Same can happen on the wheel. If you consider this point K, so we can increase, you can see the actual addendum circle of the wheel. You can increase this radius up to O2N, right? If you go beyond that, it will goes inside the base circle of the pinion, right? So if you want to prevent, interference may only be prevented if the addendum circle of the two mating gears cuts the common tangent to the base circle between the point of tangency. Which are the point of tangency? Maximum, that is M and N. In between that, if your addendum circle cuts, then there will not be a chances of the interference, right? So maximum length of path of approach means, here initially we said this K to L, this is the length of path of approach. Now we can increase this maximum up to the Mn. Out of that, M to P, that is the maximum length of path of approach, and P to N, that will be the maximum length of path of recess. Now from this diagram, this M to P can be write like this from this triangle O1 MP. This is right angle triangle, and this MP means O1P sine of phi, and this Pn, which is the maximum length of path of recess, that we can write in terms of O2P sine of phi, right? And therefore it is written the maximum length of path of approach MP, it is equal to small r sine phi. Why small r sine phi? Because O1P, this is the pitch circle radius of the pinion, and we represented by small r, and O2P, that is the pitch circle radius of the gear or the wheel, and that we represented by the capital R, and therefore maximum length of path of approach, it is MP, it is equal to small r sine phi, and maximum length of path of recess, it is O2P, that means capital R sine phi. right? So maximum length of path of contact m to n, that is equal to m to p plus p to n. So small r sin phi plus capital R sin phi, that gives you small r plus capital R inside the bracket, and outside the bracket it is sin phi. And the maximum length of arc of contact, always you are getting, if we divide to length of path of contact by cos phi, that gives you the length of arc of contact. So small r plus capital R into sin phi divided by cos phi, that gives you the tan phi. Now in case addenda on the pinion and the wheel is such that the path of approach and the path of recess are half of the maximum possible values, then we know that the equation for calculating the path of approach, general equation, it is under root of RA square, capital RA square minus capital R square cos square phi minus R sin phi, and that is equal to half of the maximum possible path of approach. And we know that the maximum possible path of approach is small r sin phi, and half of that means divided by 2. Similarly, the path of recess, it is PL equal to 0.5, and how we calculate? Under root of small RA square. RA, it is what? It is the radius of addendum circle of the pinion, minus small r square cos square phi minus R sin phi equal to R sin phi divided by 2. So length of path of contact, it is 0.5 MP plus 0.5 PN, that is R plus R sin phi. Right. Now we can calculate how much the minimum number of teeth on the pinion in order to avoid the interference. Now how to calculate this? We'll derive the equation. Let small t, it is the number of teeth on the pinion, capital T, it is the number of teeth on the wheel, m, it is the module of the teeth, small r, it is the pitch circle radius of the pinion, small r we can write in terms of the module and teeth, m into t divided by 2, right? And capital G, it is the gear ratio means number of teeth on the wheel divided by number of teeth on the pinion, and that is equal to, again we can write in terms of the diameter, so capital R divided by small r. Phi, it is the pressure angle or angle of obliquity. Now from triangle O1NP, now if you see in this diagram, this O1NP, this triangle. Now from this triangle, can we write O1N square, this is equal to O1P square plus Pn square minus 2 times O1P Pn, and cos of which angle? O1Pn, right? So same thing it is written over here. You can see O1N square, it is equal to O1P square plus Pn square minus 2 times O1P into Pn cos of O1Pn. Now O1P is what? O1P, it is the radius of the pitch circle of the pinion. O1P, this is the radius of the pitch circle of the pinion, right? Now what is this Pn? You can see here, if you consider this triangle O2Pn, then this Pn, this is equal to O2P sin phi, right? And O2P is what? O2P, it is the pitch circle radius of the wheel. So therefore, you can see this equation, it is written like this: small r square, small r, it is for the radius of pitch circle of the pinion, then Pn is R sin phi, capital R, because that is the radius of the pitch circle of the wheel, minus 2 times small r into capital R. Why small r? O1P means small r, Pn is capital R, sin phi, right? And cos of O1Pn. Now cos of this angle, how we can write this? See, O1Pn. Now here at point P, if you draw a horizontal line, then there will be 90 degree angle, and above that 90 degree, this you can see this your common tangent Mn, this is inclined at an angle phi, right? Because that is the pressure angle. So 90 plus phi, that gives you O1 Pn. So cos of 90 plus phi, right? And now we can write that cos of 90 plus phi, it is sin phi. So sin phi, and this is also sin phi, so that means becomes sin phi, sin square phi. So r square plus capital R square sin square phi minus 2 times small r capital R sin square phi. Now you can take this r square, small r square common from this equation. So here there will be 1 plus, now there is no r square, small r square, so capital R square sin square phi divided by small r square phi plus, now here there is 1 r, so if you take 1 common, so 2 times capital R sin square phi divided by small r. So this we can write, now small r square sin square you can take common outside, and here it will remain, you can write this term like this, r capital R divided by small r in bracket capital R divided by small r plus 2 outside sin square phi. So now O1n square, this is equal to this. Now therefore if you take a under root of that, you will get O1n, and that is the limiting radius of the pinion of the addendum circle. So O1n, this is equal to r under root of 1 plus capital R divided by small r inside the bracket capital R divided by small r plus 2 sin square phi. Now this small r you can write in terms of mt divided by 2 under root of 1 plus, now this you can see here gear ratio T by T, it is also equal to R by R, so you can write T by T inside the brackets capital T divided by small t plus 2 times sin square phi. And now let AP into M, it is the addendum of the pinion. Generally standard addendum it is equal to the module, but where AP, it is a fraction by which the standard addendum of one module for the pinion should be multiplied in order to avoid the interference. So we know that the addendum is what? Addendum, it is the addendum circle radius minus the P circle radius, right? So addendum circle radius is O1n, again you can see here in this diagram O1n, that is the maximum addendum circle radius, and minus O1p, right? O1p, it is the P circle radius. So the radial distance above the pitch circle up to the addendum circle, that is the addendum, right? So therefore here it is written O1n minus O1p. Now this O1n, we know that it is mt divided by 2 under root of 1 plus t by t capital T by small t plus 2 complete bracket sin square phi minus O1p. O1p is what? It is r, and r means again m into t divided by 2. So m into t divided by 2 we can take outside. So what it will remain here? Under root of this term minus 1. Right. Now m and m will get cancelled. So therefore AP it is equal to t by 2 inside the bracket under root of 1 plus capital T divided by small c inside the bracket capital T divided by small t plus 2 bracket complete sin square phi minus 1. Now from this you can write small t, this is equal to 2 times AP divided by under root of 1 plus t by t inside the bracket t by t plus 2 sin square phi minus 1. Now again we can write this equation in terms of the gear ratio. Capital T divided by small t means it is the gear ratio G. So 2 times AP under root of 1 plus G inside the bracket G plus 2 sin square pi minus 1. This equation gives you the minimum number of teeth required on the pinion in order to avoid the interference. Now similarly, we can find out the minimum number of teeth on the wheel. Here this small t, it is the minimum number of teeth on the pinion in order to avoid the interference. Similarly, we can find out the minimum number of teeth on the wheel in order to avoid the interference. Now here we consider capital T, it is the minimum number of teeth required on the wheel in order to avoid the interference, and AW into M, it is the addendum of the wheel, where AW, it is the fraction by which the standard addendum of the wheel should be multiplied. Now for deriving this, you have to consider again the triangle which is O2MP. Again if you see in this diagram, O2MP, this triangle. Now from this triangle you can write O2M square, that is equal to O2P square plus PM square minus 2 times O2P into MP into cos of angle O2PM, right? And again if you substitute the values of these, then you will get this equation. Now see, for which type of equation you are getting here, ultimately this limiting radius O2M, you are getting capital R inside the under root sign 1 plus small r divided by capital R, small r divided by capital R plus 2 sine square phi, and capital R we know the m into capital T divided by 2. So you can substitute here. Now again we can write the addendum on the wheel. It is the maximum addendum circle radius, that is O2M minus O2P, right? So O2M, it is m into capital T divided by 2 under root of this, minus O2P is m into capital T divided by 2. So m into capital T divided by 2 you can take outside, you will get this. So now you see the difference only here. Instead of capital T divided by small t, here it is small t divided by capital T, right? You are getting this type of equation. So 2 times AW divided by this. Now small t divided by capital T, it is 1 by G. So you can write that. Now here this is not small t, it is the capital T. Capital T, it is the minimum number of teeth on the wheel. So this by mistake it is written capital small t. This should be capital T 2 times AW under root of 1 plus 1 by G inside the bracket 1 by G plus 2 sine square minus 1, right? Now similarly we can see the minimum number of teeth on the pinion for involute rack. You must have heard the rack and pinion. Now when we are considering the rack means the gear having the infinite diameter, right? That means if the diameter is infinite, it will become horizontal. So you can see in this diagram, this is the pinion, the upper one, and the lower one, it is the rack, which is straight one. Now let take small t, it is the minimum number of teeth on the pinion. Small r, it is the p circle radius of the pinion, and small r, you know, you can write m into t divided by 2, and the phi, it is the pressure angle of the obligate wheel. Now a suffix r into m, that is the addendum on the rack, where a suffix r is, again here this r should be at the suffix, is the fraction by which the standard addendum of one module of the rack is to be multiplied. Now we know that since the rack it is straight, again the tooth profile, it is the straight one, and whenever this tooth profile of the rack, it comes in contact with the profile of the teeth of the pinion, that is always tangent at the point, and that tangent, it is always perpendicular to the common tangent to the base circle, that means Mn. You can see here this, the line which is drawn here, inclined line, to that profile of the tooth of the rack, it is perpendicular, right? And therefore the point M, it is the interference point. Now addendum for the rack, it is ARM. Now that is equal to, you can see here, this L to H, this vertical distance, right? H, it is the point on the pitch line, and L, it is the point on this inclined line. Now L to H. Now can you write this L to H in terms of PL and phi? See, angle phi is shown over here. So PL sine phi, and PL is what? PL, you can see here in this diagram, if you consider this OLP, this triangle, then this PL, it is nothing but the OP sine phi, and OP is what? OP is the R, P circle radius of the pinion, and therefore you can see here this ARM, that is equal to OP sine phi into sine phi. So OP is sine square phi, and that becomes, OP means R, small r, sine square phi, and small r means m into small t divided by 2 sine square pi will get cancelled. So small t, that means the minimum teeth on the pinion, small t, that is equal to 2 times ar divided by sine square phi. So this is the minimum number of teeth required to avoid the interference on the pinion for the rack. Right. Now we'll see one numerical. A pair of involute spur gear with 16-degree pressure angle, so phi is given 16 degree. The pitch of the module, it is 6 mm, is in mesh. The number of teeth on the pinion, it is 16, and its rotational speed is 240 rpm. When the gear ratio is 1.75, find in order that the interference is just avoided. The addenda means addendum on the pinion and the gear wheel, and second, the length of path of contact, and third one, the maximum velocity of the sliding of the tooth on either side of the pitch point. That means on the left hand side of the pitch point and on the right hand side. Left hand side of the pitch point there is a length of path of approach, and on the right hand side of the pitch point there is a length of path of recess. So what is given here? Pressure angle phi is given, module m, it is 6 mm, number of teeth on the pinion, it is 16, speed of the pinion n1, it is 240 rpm. So from this n1 you can find out omega 1 2 pi n by 60, you will get 25.136 radians per second. Gear ratio is given 1.75, so capital T divided by small t, and therefore the capital T, it is equal to capital G into T. G is given 1.75, T is known to you 16, so you can calculate the capital T, that is 28. Now first we'll try to calculate the addenda on the pinion and the gear wheel. You know the equation for calculating the addendum on the pinion and the wheel. AP into m, that is equal to m into 2 divided by 2 in bracket under root of 1 plus capital T divided by small t inside the bracket capital T divided by small t plus 2 bracket complete sine square phi, and outside the under root sign it is minus 1. So just substitute the value of m and t. M it is 6, small t 16 divided by 2, 1 plus capital T, it is 28, we calculated 16, 28 divided by 16 plus 2 sine square, pressure angle is given 16 minus 1. If you substitute all the value and if you calculate that, you will get the addendum on the pinion, it is 10.76. Similarly, addendum on the wheel, the equation is small m into capital T divided by 2 inside the under root sign 1 plus this equation minus 1. You just substitute the value, you will get addendum on the wheel is 4.56. That is your first answer. Then the length of path of contact. Now we know that the capital R, that means the pitch circle radius of the wheel, capital R, it is equal to m into 2 divided by 2. You just substitute the value, you will get the capital R 84 mm, and the pitch circle radius of the pinion will get 48 mm. Now we can calculate the addendum circle radius of the wheel. So RA represent the addendum circle radius of the wheel, capital RA, that is equal to capital R plus the addendum on the wheel, which you have calculated. Capital R is 84 plus addendum for the addendum of the wheel, now here you should correct this. Addendum on the wheel, it is 4.56. So you should substitute here 4.56, that gives you 88 point something. There, this is wrong. And the addendum circle radius of the pinion, small ra, equal to small r plus addendum on the pinion. Addendum on the pinion, it is 10.76. You check these values and then substitute here, right? So this way you can find out the capital RA and small ra, and then with the help of this you can find out the length of path of approach. Length of path of approach, it is under root of small capital RA square minus capital R square cos square phi minus capital R sin phi. You substitute the value, you will get the Kp, length of path of approach, and the length of path of recess, it is Kp, this is length of path of approach, and Pl, this is length of path of recess. Just check this, right? Under root of this equation. So if you substitute the value, you will get this value and length of, similarly, you can find out. If you add the Kp plus Pl, you will get the length of path of contact. Then the maximum velocity of sliding of the tooth on either side of the pitch point, let omega 2, this is equal to angular speed of the gear wheel. We know that omega 1 divided by omega 2, it is equal to nothing but the capital T divided by small t, and that is given 1.75. So from this you can find out omega 2. Now once you get the omega 2, then the maximum velocity of the sliding of the tooth on the left side of the pitch point, that is at point K. So omega 1 plus omega 2 into the Kp. Kp is what? Length of path of approach. So if you substitute the length of path of approach here, you will get the maximum velocity. And the maximum velocity of the sliding teeth on the right side of the pitch point, that is at point L, and for this omega 1 plus omega 2 multiply by the length of path of recess, that gives you this value. Okay, thank you very much friends. Just take care.